Hello, this is Mr. Waterman. This is lesson 11.3, perimeter and areas of similar figures. So in the past we have dealt with similar figures. These are figures that have corresponding sides that are congruent. So they're the same shape, but they're different sizes. And corresponding sides are in proportion to each other. So, figure A is a 1 by 1 square. Side lengths are both 1, therefore it has an area of 1. Figure B is a square that has twice the side length, so it's made up of 4 of the smaller squares. So both sides have a side length of 2. So what we have going on though, if I look at the ratio of lengths, so if I take a side length from figure A and compare that to a side length from figure B, you get a ratio of 1 to 2. If I look at the ratio of areas, like I said, the area of figure A, the area is 1. The area of figure 2, you just count up the squares, they're all 1 by 1, you get an area of 4. So take the side lengths of 2 and square it, and you also get 4. So if I write the ratio of areas of A to B, I get 1 to 4. If you look at that, that's the same as the ratio of the lengths here, the 1/2. If I take the 1/2 and then square it, I get the same result. So the concept is that the ratio of areas between similar figures, in order to arrive at it, you simply take the ratio of the lengths, two corresponding sides of the similar figures, and square them, and that will give you the ratio of the areas. So let's go try and put that to use. So we have an example here. In the diagram, figure 1 and figure 2 are similar. Remember this funny little sideways S means similar. So on figure 1 we have a side length over here of 18, and on figure 2 the corresponding side length is 10. Okay, so if we write a ratio of the area of the lengths, A to B, that's going to look like let's see, ratio of the lengths. So if we just take the side length A over B, that is going to be 18 to 10. So that's going to simplify down to 9 to 5. Okay, remember when we're using ratios, even though it looks like a fraction, we pronounce it, the fraction bar, as 2. So it's 9 to 5, top number to bottom number. So ratio of perimeters is going to exactly equal this ratio of lengths. So if I were to add up all the side lengths, if I knew them, you would find out that this would also simplify to a ratio of 9 to 5. Now the ratio of the areas, as we learned on the last slide, you simply take corresponding side lengths, so I can take the ratio of the sides. We can even use the simplified version of 9 to 5. And I square those both, and that will give me the ratio of the areas of these two similar figures. So that's going to, if I go ahead and square the 9, I get an 81. If I square the 5, I get a 25. So the ratio of these areas is going to be 81 to 25. So in other words, the area is a little more than 3 times. The area of figure 1 is a little more than 3 times the area of figure 2. So let's have you try one. Problem 1. I have two similar figures that I've drawn here. We can call this figure 1. So figure 1 has a side length of 4, and the corresponding side on figure 2 is 3. So I want you to find the ratio of the two areas of these similar figures. So I'd like you to do the side length off the right to this side. Length up to left. Okay, sorry. A little lag there. Let me get this thing going. So we'll call that A, and this will be B. Oops, that was supposed to be a B. That looks like a 6. Let's try this again. It's a little lag, a little slow, sorry. There we go. So we have A equals 4, B equals 3, so go ahead and find the ratio of the areas. And put that in your response. So that's the end of video 11.3.